Hello.
Good evening, sir.
Hello, how are you?
I'm fine, thank you.
Okay. So I'm sure you guys got my message. I'm sure you got my message that we'll be starting late, right? Hello.
Hello.
Yes. Hello.
How are you all?
Hi.
All right. So yeah, let us begin. Today we'll be working on completing the standard deviation and their application, how to using standard deviations. I've shown you how to calculate it for ungrouped data. Now I'm going to describe how to use it, and then we can take a look at how to calculate the grouped standard deviation. Okay. So now, interpreting standard deviation, I explained that standard deviation is how far a data value have strayed from the mean. If you look at these charts here, you can see that this bar at the center represents the mean. You can see the mean of 5. In this case, there's no number that strayed away from the mean. So that's why the standard deviation S is 0. Here, the mean is still 5. You can see the center 5. Some of the data value have moved away, a little bit away from the mean. So it's approximately 1.2. Again, the mean is 5. Here, still the 5. They moved away 3 times. 1, 2, 3. 1, 2, 3. So on both sides, they move away significantly. That's why the standard deviation is 3 here. Okay. So basically, like I said, is how far this is a pictorial way of explaining this using a diagram. However, where we are concerned today, where we focus more attention today is on 2 rules that involves the use of standard deviation. One of them is the empirical rule, and the other one is the Chebyshev. See, the Chebyshev theorem. So let us start with the empirical rule. According to the empirical rule, it says we use empirical rule only for data sets that are symmetric. When I was describing the shape of distribution last week, I explained symmetric, skewed, left skewed, right skewed. So symmetric or bell-shaped distribution. That kind of distribution, like this one here, see the chart, is symmetric. The same, this is halfway, the center of the mean, is the same on the right side, on the left side. So we call it symmetric or normal or bell-shaped distribution. So that is where we use the empirical rule, which means that if the distribution is not a bell-shaped distribution, or it is not mentioned that this is from normal or symmetric, you cannot use the empirical rule. So what does the empirical rule say? It says for data with a symmetric or bell-shaped distribution, the standard deviation has the following characteristics. 68% of all the data values lie within one standard deviation of the mean. About 95% of all the data values will lie within 2 standard deviations. Then about 99.7% of data values will lie within 3 standard deviations. Now, this rule is set on stone. So that means they apply for in case of normal distribution. And we call them empirical rule, or can call it 68, 95, 99.7 rule. The principle behind this rule is above this this level of statistics. So there's no point explaining it here. But I'm going to simplify it in a way that you understand. So now look at this chart. It said 68% lie within one standard deviation. You can see it here in this blue column. 68% divided by 2. That means 34% on the left side and 34% on the right side, making it 68%. Now, to get this one here, which is the, you can see that this is x minus 1 standard deviation. You remember in your algebra class, when it is 1x, we just write it as x. So when it is 1 standard deviation, we just write it as s. This means x bar, which is mean, minus 1 standard deviation on the left side. On the right side, we have mean plus 1 standard deviation. And you can see this 8% here within 1 standard deviation. So 34, 34. Now, 95%, according to the empirical rule, of all data values lie within 2 standard deviations. Now, the data value that are within 2 standard deviations are considered the normal. Normal, for example, the normal blood sugar level for somebody who doesn't have diabetes fall within a particular range. The normal normal blood pressure we have, the normal average height of an adult fall within a given normal range. So, but data value within for this part, 1 standard deviation and this 99.9%, sorry, 3 standard deviation. Any data value that's above 2 standard deviation is considered unusual. So for the one that are within the 95% or 2 standard deviation are considered the usual. When I say usual, I know that some of you have my say what he sees, what does he mean by usual? Let me spell it, what I mean by that. This is usual. See, you can see this, right? So, how do I make it bigger? Okay, this is what I mean, usual. So, something that is normal. Okay, now for the other parts, we have 95% fall within 2 standard deviation. So now you have 68%. So you just to get this 13% here, what you're gonna do is subtract 68% from 95, and the answer you get there, you divide by 2 to get this number here. So let me show you what I mean by that. I got 95 minus 68 give us 27. Okay. Now, if you divide that answer by 2, give me 13.5% on the left side and 13.5% on the right side. And you can see it here, 13.5%, 13.5%. And that is for 2 standard deviation. So then on the left side, it is x bar minus 2 standard deviation. S bar is the mean. And on the right side is S bar plus 2 standard deviation. So if you follow the same process, 99.7% minus 95% and divide by 2, you get these numbers here. So just this table, the table is given, and this is how it is. I'm sorry, the chart is given. So this is how it will look, and you'll be using it for solving a problem that involves empirical rule, so long as that the data set is normal or bell-shaped. Okay. So question before we start, any question before we start using it? Okay, no question, very good. Now let us see how we can use it. You say in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States, women of age 20 to 29 was 64.3 inches with a standard deviation of 2.62 inches. Estimate the percent of women whose heights are between 59.6 inches and 64.3 inches. So to do this, first of all, you have to put these numbers here, where you have x bar minus standard deviation, then S bar plus standard deviation, and so on and so on. All these numbers, calculate them. After that, you can be able to estimate the percentage that are between 59.06 inches and 64.3 inches. So let us do it. and then I'll take you to where we can do it. According to the questions, let me write these things down, and then we can calculate it. According to these questions, the mean is 64.3 inches. So X bar, 64.3, and standard deviation S is 2.62. And they're looking for the range of the percentage that fall within 59.06 and 64.3. So 59.06 and 64.3. So let us, I'll take you to the workbook, and we'll start putting this together. So we'll have the mean. Okay, let's see. Insert the mean. 1 minute. I gotta move this thing away. Let's see. Okay. The mean. Okay. Mean X bar equals 64.3. So I'm gonna take this to the amend workbook, which is here. Okay, what is it? This thing just disappeared. Okay, the mean is this. And the standard deviation S equals 2.62. So now we're going to get the numbers for all these numbers here. Mean, which is 64 points. You can see right here at the center, 64.3. That's for this mean right there. Okay, let me make it a little bit larger so you can see it from better. Okay. Now let us get the left side and the right side. So the left side, mean minus 1 standard deviation. So let's see. For this one, mean minus 1 standard deviation becomes mean is 64.3. I have 64.3 minus mean minus 1 standard, that means mean minus 1 times this, minus 1 times the standard deviation is 2.62, which we can get from the calculator as we have, okay, 64.3 minus 1 times standard deviation of 2.62. We close it. Give me 61.68. 61.68. I got 61.68. 61.68, which is right here. So you gotta put it right here. 61.68. So I'm gonna go back a little bit to this. Now you repeat the process for mean plus 1 standard deviation. So I'm gonna copy from here. Mean 61.68 64.3 plus. So instead of minus, you put plus because you're getting this one here. 1 times the standard deviation 2.62. Okay. Now I'll take you to decimals, to calculator so you can see it. So I'm going to change this to plus. Give me 66.92. 66.92. It's 1 minute. Yeah, 66.92. Okay, good. We got 66.92. So I'm going to put it right here. 66.92. So once we get all these answers here, we can be able to answer the question. Remember, the question says, according to the question, it says, find the estimated percent of the women whose height are between 59.06 inches and 64.63 inches. So we get all these calculations, and then we'll be able to figure that out. Now let us do for 2 standard deviations. See, 2 standard deviations right here. Mean minus 2 standard deviations. So I'm going to do mean, which is 64.3 minus 2 times standard deviation of 2.62. Okay, so I'm going to put it in the calculator so you can see it. So I'm going to change this to 2. I'll make this a minus sign. That gives me 59.06. 59.06. 59.06. So I'm going to put it here, 59.06. So I'm going to adjust this. Okay. So this one goes for this part. And let us repeat the same process for mean plus 2 standard deviation for the right side. So I'm going to repeat this. I'm going to use plus now. 64.3 plus 2 times 2.62, which represents our mean plus 2 times standard deviation. So I'm taking you to calculator so we can figure this out. So I'm going to change this to plus sign. Give me 69.54. 69.54. So I'm taking you 69.54. 69.54. So I'm going to put it here. 69.54. That is for this one here. Now for the last part, which is for 3 standard deviation, I will repeat the process. Mean, you see, on the left side, I have mean minus 3 standard deviation. So you have 64.3 minus 3 times the standard deviation of 2.62. Okay. So I'm going to take you to the calculator again to get this taken care of. So I'm going to change this to 3 and this one to minus sign. It gives me 56.44. 56.44. So 56.44. 56.44. So I'm going to put it right there. 56.44. I'm going to adjust this so that it will make it to be the same size as the rest of them. Okay. And then adjust it so that it's going to, oops, excuse me. Okay, so it's going to be like this. And this one, so this is for this one. This one is for that one. Okay, here. And of course, now let's do the same thing for the plus side. I mean, repeat the same process, but use a plus sign to get the other side. So I'm going to do 64.3 plus 3 times the standard deviation of 2.62. Okay, I'm taking you to the calculator to figure this out. So I'm going to make this a plus sign. I get 72.16. 72.16. So I'm taking about 72 0.16, 72.16, which is right here, 72.16, 72.16. Okay. Now, we're looking for, okay. Now we got all the numbers. Now let us answer the question. The question says the percentage, find the percentage, estimate the percentage, estimate the percentage of women height whose height are between 59.06 inches and 64.3 inches. So now the percentage of women, it will now become here. I type it here. So the percentage of women will now become percentage of women of that height will now become, we look at it, it says between 59.06, this is 59.06 here, and 64.8, from here, 64.3. So it is from here, let me use a diagram, to a chart to put it. It's from here to here. See? I'll make it tick. See? You can see from here to here. And when you add them, you're going to be 34% for this one and 13.5% for this one. So you have 13.5% to be 13.5% plus we have for this one is, for this part from here to here is 34%. 34% are giving us, so 13.5 plus 34. So if you add them 13.5, 13.5 plus 34, 13.5 plus 34% give us 47.5%. 47.5%. So 47.5% of women have that height. Yeah. Any question?
You made that 34, 35, or?
How do I get it?
No, not how do you get it. When you were doing the calculation, did you just do 13.5, 34, or 35? Because
right here.
34, right? It was my eyes. I was just making sure.
Remember you said from 59.06 to 64.3. So from here, you see my line? I draw a line from here to there. So from here, you see that the boundary included in that line is 34 and 13.5. So you add them together. That's how I got it. Is that the question you asked?
Sure, yes. Go ahead. Continue.
Does that answer your question? Okay, good. Now, and it is also done in the PowerPoint. It's even here in the PowerPoint, but the PowerPoint does not explain it very, very well. That's why I decided to work it out. So you can see that it is from here to here. So the PowerPoint didn't get these numbers here. So that's why I went down there to get the numbers. You can see that 34% plus this, then give you 47.5%. Any other question for me? Any other question? Okay, good. Now, sometimes they might ask this question in a different way. Look at this one here. Look at this one. I'll show you. So it says here that past results, make it a little bit bigger. Now, unfortunately, I don't know what happened yesterday. The video I recorded, I tried to upload it, but I think the problem is from YouTube. It recorded only 20 seconds. That's why I didn't post it. So we lost basically the whole video yesterday. But this today, I'm more careful today, and hopefully it won't happen again. So now, like I said, this question might be asked this way. It says, past results from National Health Survey suggest that the pulse rate of women have a mean of 76 and a standard deviation of 12.5. Assume that the distribution is symmetric. So you see, they will have to tell you that it is symmetric or that it's normal. That is how you know you're going to use the empirical rule. Now it says, find the minimum and maximum usual pulse rate of women. Usually, the data entries that are within 2 standard deviations are considered usual. Then it says, then determine whether a pulse rate of 110 will be considered unusual. So let's see this. Let's look at it. Solution. Okay. Now, it said that the mean for women has a mean of the pulse rates, a mean of 76. So I'm going to use this symbol for the mean here, mean of 76. Okay. That's 1 minute. And the standard deviation of 12.5. So I'm going to use this symbol here. Standard deviation of 12.5 for the population equals 12.5. And we can answer part A. Part A says, find the minimum usual and unusual. So for the usual, remember I told you that the usual will be 2 standard deviation, which means here to here. And for that, we have mean plus 2 standard deviation on the right side and mean minus 2 standard deviation on the left side. That we consider usual. So that means for the lower side, okay, we have mean minus 2 times standard deviation. Why do we use this formula? Because it falls within the usual rate of this 95% from here to here, which is the 2 standard deviation. Remember, it says here that the data entries that lie more than 2 standard deviation from the mean are considered unusual. So anything that lie within the 2 standard deviation, which is from here to here, which has 2 standard deviation, is usual. That's why we are using this, and that's this one for the lower side, this for the upper pulse rate. So we have 76 minus 2 times the standard deviation of 12.5. So I have this can give us from the let me write it down so you can work it out on the calculator. 76 minus 2 times 12.5. Okay. I'll take you to the calculator. 76 minus 2 times 12.5 give me this is 12.5. I wrote 12.5. Give me 51. So I'm gonna have 51 here. Okay. 51 beats per minute. Okay, per minute. Now, on the upper side, the same thing, but this time we use plus. Okay, the upper side will be this side mean plus 2 standard deviation. So we have it as mean plus 2 times standard deviation. Okay, which is 76 plus 2 times 12.5. So we just change this to excuse me, class. Just 1 minute. Hello, Oliver. Hello, Oliver. Come watch your guys. What? I'm in the class.
Okay.
I'm in here online.
Quick question.
Yes, I'm with me.
Okay, your phone number gave me.
Yes.
Okay. I can say I'm going to cash. I can be going to cash up. I give it to
Okay, I'm finished here. No. I don't know. I'm made the lecture on Zoom.
Okay, you better say
Or H number. Okay. All right. Okay.
So can you have 443-797-4772?
All right. Yeah.
Okay.
Okay. Bye. Class, I'm so sorry about this. It's an urgent call. So now we're gonna have this. Let's put this in the calculator. Make it a plus sign. 101. So I'm gonna put 101 here. 101 bits per minute. So now, with this, we have answered the question. You say find the minimum and maximum. So this one is the minimum here. This is the minimum. And this is the maximum bit per minute. Any question before I solve part B? Hello?
I know I don't have no questions, Professor.
No questions.
Part B says, then determine whether a pulse rate of 110 will be considered unusual. So this is the usual, the normal bit, 51 bits to 101. And it says a pulse rate of 110. A pulse rate of 110 bits per minute. You can see that it doesn't fall within this interval. It falls outside. It's bigger than the interval. So it is unusual because it falls outside the interval. So this is another way you can ask this empirical rule question. So remember, we use empirical rule if and only if we are told that the data set is symmetric or barrel-shaped, or that is normal. That's the only time we use it. Now, but how about situation? Oh,
Hello, sir.
Yes, ma'am.
Yeah, I want to ask a question. How can you tell when to use the plus sign or the minus sign?
Well, if you look at the chart, can you see the chart I have here?
Yes, sir.
Yes, that's how you know. Anything that is on the lower side, use on the left side is minus. So when you do the minus side, you also do the plus side, because the minus side gives you the lower side. The plus side gives you the upper side. So it's a range. So if you do for two, like the one we just did, it says normal range. So, and I explained before that data sets that fall within two standard deviations are normal. So there it was two sides. It has had two sides. The lower side, which is x star minus 2 standard deviation, because it is the lower side, you use minus. Then the upper side, you use the same thing, but you use plus. So how you know is based on the question they gave you. If they ask you to find the two normal range or the two usual range, that means you're going to use S bar minus 2 standard deviation and S bar plus 2 standard deviation. But if it says more than a certain range, like this one, the first one we did says between 59.06. You say what percentage will fall between 59.06 and 64.3? In that case, you have to get odd numbers. You have to go here and get your X. Here, our S bar is given as 64.3 inches, and the standard deviation is 2.62. So you are going to use all the ones that involve S minus standard deviation on the left side. Then use all the ones that involve S plus standard deviation on the right side, like we did here. So once you can finish that, get all the numbers for each of them, which is for the X minus 1 standard deviation, S minus 2 standard deviation, S minus 3 standard deviation. Then on the right side, you get S plus 1 standard deviation. What I mean is, I mean S bar, that's mean minus 2 standard deviation. You get all of them. Then you can now find the one that falls within that range. In our own case, it says between 59.06 and 64.3. That means between here and here. Then you add the percent given. That will give you the answer. Does that make sense?
Yes, sir. Thank you.
Welcome. So now, how about the situation whereby the data set does not is not normal or is not bell-shaped? For that type, we use what we call the Chebyshev theorem. It is named after the Russian mathematician that derived it. According to this theorem, the portion of any data set lying within K standard deviation, or the mean, is at least 1 minus 1 over K squared. So K is what you get the K value through a calculation. There's a formula you use for that. I will show you how to get the K. So if K is 2, for example, just plug in 2 in this formula and then multiply the answer by 100. I'm going to show you now. But here, when K is 2, according to Chebyshev, it will be 1 minus 1 by K squared, which will be, 1 minus 1 over K squared, 1 over K squared, which is 2 squared this time. 2 squared, you close it. Okay. Actually, 1 minus 1 over 2 squared. I'm going to put another parenthesis here. Close it. Then times 100. Give you some 5%. That's how we get some 5% here. See? So at least, you say for any portion of any data set lying within K standard deviation, or the mean will be at least 1 minus 1 over K squared, which means for K2, it will be at least 75%. And if you change K to 3, you're going to be 8.9%. As you can see from here, if I change K to 3, instead of 2, I'm changing to 3. Okay. Change to 3. See, 8.888, which is 8.9%. Now, and so on and so forth. Remember, we use the Chebyshev theory for all type of distribution, whether it's normal or not normal. How do we get the K? Like I said, K is calculated. We use this formula for finding the K. Upper end minus mean divided by standard deviation. For the lower side, for the left side. For the right side, use lower end minus mean divided by standard deviation. We'll come to this in a few minutes. Let us try one example first here. It says the age distribution for Florida is shown in the histogram. So apply Chebyshev theorem to the data using K equals to 2. What can you conclude? Okay, so this one is they tell us that it is mean is 39.2 and standard deviation is 24.8. So and they give us that K is 2. So what do we conclude from this information? So first of all, let's look at it here. Remember, on the left side, you use mean minus 2 standard deviation because they told you that K is 2. So that means mean minus 2 standard deviation. And our mean is 39.2, which is right here, minus 2 times standard deviation. This standard deviation is 24.8. It gives us negative 10.4, which is because we can't use negative 10.4, so we just call it 0. Now, because our age cannot be negative, nobody have negative age. Then for the upper end, you use mean plus 2 times standard deviation, which is 39, just the same thing, but just change this to plus sign, and that's give you 88.8. So from this information that you give us, that K is 2 and the mean is 39.2 and the standard deviation is 24.6, we can conclude that at least remember that 2, this number 2, K2, is associated with 75% according to Chebyshev theorem. So based on this information, all these 3 pieces of information, we can conclude that at least 75% of the population of Florida is between 0 and 88.8 years old. Any question for me?
No.
Very good, very good. Now, next thing is another way this question might be asked. It says the average check at a local restaurant is $36.42 with a standard deviation of $8.15. Excuse me. It says, what is the minimum percentage of checks between $15.25 and $57.61? So for this, we're gonna find the upper and lower end. We are told that the average is 36.42 and the standard deviation is 8.15. The upper end is 15. So actually, this should be the lower end. I wrote upper end by an error. This is the lower end. This is the upper end is 57.6. Let me write this down. So please, you can adjust it in the PowerPoint that you have. So the upper.
Hey, excuse me. Can you check your what's it called? Your waiting room really quick. Someone is trying to get in your class.
Get it in the chat room. Okay. Okay, let me see. Waiting room, right? Let me see if there's 1 minute.
If not, they probably gave up or something.
I didn't see anybody in the chat, and this is the waiting room right here. Nobody's. Well, I'll wait. If he tries again, then I'll let the person in.
Okay.
Yeah. So the mean is 36.42. Standard deviation is 8.15. Now the upper end is 57.61. Lower is 15.25. So, like I said, this one should be lower. I wrote it up by is a typo, and this is a PDF, so I can't change it now. Anyway, so this one is, but know that this is the upper, this is the lower. Now, either way, so let's find the care. Before we can answer this question, we need to find the care. Now, the formula is this: care is lower minus mean divided by standard deviation. So, which is 15.25 minus 36.42 divided by 8.15. So I'm going to put this in the calculator so you can see how I got this. Remember, negative sign means that it is on the left side, not that it's lower. Just it means that it's on the left side because we're using absolute values here. So if the answer is negative, it means that it's on the left side. So I'm going to have this done. The calculator, take you there. So I have with the calculator. So you have we got lower end is we have 15.25 minus mean of at 6.42. Okay, divided by standard deviation of 8.15. You can see negative 2.597, which is negative 2.6 approximately. And that's why I write that negative 2.6 here, negative 2.60. Now, if you use the upper end, you get the same results. Let's double check it. So we'll have this here. Instead of using the upper end, I'm going to use the lower end. I'm going to use the upper end, which is 57.61. So you can see the 2.6 approximately. So we got both of them. Then we can now answer the question. This question says, what is the minimum percentage of checks between 15.25 and 57.61? So now we have our K as 2.6. So like I said, if it's a negative, it's just that it's on the left side. To tell it on the left side. So it's 2.6. So using K equals to 2.6, we plug it into this formula for Chebyshev. If you remember, 1 minus 1 over K squared times 100%. So plugging it in, we have 1 minus 1 over K squared, 1 over K squared. Our K is 2.6, so 2.6 squared. Okay. And close it here. All right, close it right here. Then times 100, which is 85.2%. You can see where I did it here, 85.2%. So we can say that at least 85.2% of the checks are between $15.25 and $57.61. Any question for me?
Yes, sir. Sir, can you please do the calculation again so I can see?
Which of them?
The one you use the calculator with.
I use it for twice. Or is it the last one?
Yeah, the last one.
That is 1 minus K, 1 over K square, right? That's the one, right?
Yes, sir.
Okay, good. So we find our K to be 2.6 from here. See? 2.6. Or you can even, whether it's negative. Negative is just to tell you it is on the left side. So we have 2.6.
I understand that one.
Okay, good. So the thing is this to imply the same. You know how you do if you like to extend it, you can get your K square first and put it in. But if you want to put it direct on the calculator, you can do it this way. So I'm gonna clear it. So put parentheses. So parentheses will make your work follow order of operations. You know. So 1 minus, for the 1 over K part, put it in parentheses, 1 divided by K squared. Our K is 2.6. So 2.6 squared. Can you see that?
Yes.
Then close the parentheses. Now, see, look here. You have 2 opening parentheses here. So to balance it, you have another two closing parentheses. So it will balance 2 opening parentheses, 2 closing parentheses. Then multiply your answer by 100. Is 85.2%. Have you seen that?
Yes.
You said 5.
Now?
I'm sorry. You said 5.2. It says 85.2.
Yeah, 85.2%. Yes.
Okay.
Yeah, 85.2.
Why do you square the 2.6?
Because the formula says here, see K squared. So 2.6 is the K. That's why you square it.
Okay.
So 85.2% of the checks are, at least 85.2% of the checks are between 15.25 and 57.6 $1. Any other question? All right. So now I can explain how to Remember we did standard deviation, how to calculate it yesterday. Now I'm going to explain to you how to calculate it if it is group standard deviation. In that case, you insert the frequency in the formula. So you're going to be, standard deviation will become sum of square root of sum of x. Standard deviation is always the square root of variance. So I'll get the variance and then find the square root of variance. That gives you the standard deviation. So sum of x minus x bar squared times frequency divided by n minus 1. So the formula inside this radical sign is the formula for variance. When you find the square root of variance, you get the standard deviation. Usually an example will help you to understand this. It says here, it says, you collect a random sample of the number of children per household. Number of children per household. It's right. They are right here. In 1 minute. So see the number of children in 50 households. It says find the samples mean and sample standard deviation of the data set. So the first thing you do is to put them in groups. If you look at it, you can see that each number, S represents each number here. This one is x1, this one is x2. So each of these numbers here are represented by x. So how many ones do we have? So let's start with 0. The lowest number here is 0. How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 zeros. You can see, oh, it says 10. So let me see. 1.
Not the one on the
2, 3, 4, 5, 6, 7, 8. Okay, 9, 10. 10 zeros. So for 0, the frequency is 10. Now for 1, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19. So 1 is 19 of them. So you follow the same process for 2, 3, and 4. Get all of them together. Now to get the mean, you multiply x times f. I mean 0 times 10 is 0. 1 times 19 is 19. 2 times 7 is 14. You do that for all of them, and then you add the whole thing. 0 plus 19 plus 14 plus 21 plus 8 plus 5 plus 24 will give you 91. You can double check it on your calculator. Then if you add all the frequencies, you get 50. So you plug it in here. X bar, sum of x times f. We do this yesterday. Divided by n. That means sum of f, x times f is right here, 91. Put it right here. And sum of f is 50, which is this one. You divide it. So 91 divided by 50, we got 91. Just double checking. 91 divided by 50 give us 1.82. 1.82. So we have excuse me here. So which is 1.82. So if you round it, it's gonna be 1.8. With this, you can now find your standard deviation, the x numbers, the frequency. That is this two that we have. This one that you already have, 1, 2, and okay, you have them here. Then it says, let us find the deviation. X minus x bar. Our x bar is 1.8 already. We have it here as 1.8. So x minus x, the first one is 0 minus x bar, means 0 minus 1.8. You can see this as 0. So you have 0 minus 1.8. Give us negative, sorry, I made a mistake, 1.8. Give us negative 1.8. So we can see it here as negative 1.8. So 1 minus x bar means 1 minus 1.8, which is negative 0.8. So you do it for all of them. But these answers that you got, you square them here. So negative 1.8 squared, for example, will be negative 1.8 squared negative 1.8. I close it then, squared is 3.24. 3.24. 3.24, which is you can see from the chart here, 3.24. See, 3.24. So you follow the same process, negative 0.8 square, give me this, square all of them. Then the answer you get from this squaring, you multiply by the frequency, which is this number here. So you can say 10 times this answer. As you can see, 3.24 times 10 gives you 32.4. 0.64 is the answer you have here. 0.64 times 19. Where did 19 come from? From this frequency right here. Give you 12.616. Do it for all of them so that you add this part, you get 145.40. So with these two information, you can now get your standard deviation. The total of this one here, you can see right here. Now you can now put in the formula. Standard deviation now becomes sum of x minus x bar squared times f, which is right here, 145.4. Can put it right there. Divided by n minus 1. What is our n? Our n is the total that we have, which is 50. So if you pick this one, which represents sum of s minus s bar squared times frequency, it's 1.540 is fit right here. N is 50, put 50 right there, minus 1. And that will give you 1.7. Double checking this. I'm gonna have, let me write it down, then double check it. So have square root of 145.4 divided by 50 minus 1. Let's double check it. Okay. So you have clear this. The square root of 145 divided by, I got 50 minus 1. Okay. So 1.7. So 1.720, which is approximately 1.7, is the standard deviation here. So the standard deviation is about 1.7 children. So now we have already done standard deviation yesterday. This is just when you want to do a group one, you can use this. Now, let us round up with this topic, which is called the coefficient of variation. This simply means using standard deviation to describe how one thing varies with the other thing, and one variable varies with the other. We use it. I'll give you a typical example. If somebody who lives in New York and pays rent and make $70,000 a year. I mean somebody who lives in the city of New York and is paid $70,000 a year, and somebody who lives in Baltimore City and is paid $50,000 a year. And you might see that comparing them, the standard of the cost of living in New York and Baltimore, you might see that even though the other person is paid $70,000 a year, the standard of living is almost as being paid $50,000 a year living in Baltimore City. So we use these two to compare the variation of the two. Those stockbrokers use this a lot to compare stocks versus the indexes. So the formula is this: standard deviation divided by mean times 100%. So that's it for the population. If you're using the population, but if you're using the sample, which is what we'll be using most of the time, you're going to have a standard deviation divided by the mean times 100%. Now let's look at it here. It says the table below shows the population height in inches and weight in pounds. See, we are comparing heights and weights. in pound. Now, find the coefficient of variation for the height and the weight, then compare the results. So now, which means to do this, we need to calculate the mean height and mean weight, and calculate the standard deviation of the height and weight. Now, I have already shown you how to do this to save our time. I will show you how to use Excel to calculate the mean and standard deviation. So we're going to use that. It's already calculated here, but we're going to show you how to get it fast using Excel. So I'm going to take you to Excel right away. I have the height and weight. Let me make it a little bigger. You guys can see the screen, right? Can you?
Yeah.
Yes, yes.
Look at the mean, the average, and this is the standard deviation. Standard deviation. Okay. So since we're using a sample of this children, is it children? Let me make sure it's not children. Yeah, weight, okay, of members of a basketball team. Okay, good. Okay, so for the mean, we use equals. Remember, whenever you want to do calculation in Excel, put equal sign first. Mean is average. Times average. To come out, double click on it, and highlight from here. Okay, close it. Okay, now one thing good thing about Excel is that when you do one calculation, you can copy the formula and it will calculate the other one.
But I hear something.
Are you talking to me, ma'am?
No, I'm sorry. No, my mistake.
No problem. Excuse me. I thought you were asking a question. That's why I asked. So you copy and paste it. Copy it in and then close it. Then press the enter key. Now, like I said, I was saying, once you do the one calculation, you can copy the formula to the next cell. It will calculate the other one. So I'm going to copy it here. How do I do that? You see this small dot here? I see a small dot here. When you move it, when they move the cursor there, it will change to this a skinny cursor. Once it change, click, hold, and drag. It will calculate the mean for this one. So just make it to the smart place. Okay. By formatting cells, and there's number, and then you see decimal places is 2. If you like, you make it 1, then click OK. So this gives us the mean here. Now for the standard deviation, you can this is a sample, I believe, because this is a sample of basketball players. Is it so you can do STDEV because it's sample. You're going to use stdev.s. Then highlight it. Close the parenthesis. Then press the enter key. Now, and then copy it to next cell. It will calculate for this next cell. Then right click it and format the cells to make it to the smart places. So this becomes your standard deviation. I use. Okay. Now, these are done already inside the PowerPoint. So you can see what you have here. Let us go to the PowerPoint now. So we have the mean and standard deviations for these two values. 72.8 for height.
Sir?
Yes, ma'am.
Sorry to cut you short. When I tried to use the Excel to do the calculation, one of the calculations. And then I don't know if you can go back to the, So like this 72, I put my cursor there and then drag it. Instead of showing me all the numbers that is there that I typed before, like the 74, 68, the 2 repeated all the way down. I don't know what happened.
What repeated?
Like the 72, I placed my, the way
you mean you didn't get the 187?
No, it didn't just copy 72 down.
Yeah,
Like the whole figures changed to 72.
Then click on undo here. Click on undo, then repeat the process.
I tried and tried, but
so watch me now. Watch me.
no,
Maybe
not this particular one. I mean the one of the ones we did that I tried to do. Then
maybe when you are dragging it, you didn't drag it very well. See, to drag it, you have to make sure that this cross changes.
Yeah, it showed the cross. I
Then
don't know what happened. The whole figure changed to the first number I had there, like the 72 there. Everything turned 72 all the way to where I stopped.
So now, but this one that we're doing now, were you able to do this one correctly?
I can't do it because I'm using the computer to
Okay. When that kind of thing happen again, just click on do and then do it again over again. Probably when you are, I think I know what you are saying. If you click from here, I don't know. Okay, let's see. So long as you click, maybe if you sometimes your finger might click on something while you're dragging it, it might cause that kind of thing to happen.
So I have a question. You just drag it. You don't have to do anything else while you're dragging it.
Yeah, yes, just click and drag it. That's it.
Click and drag it.
Then you want me to do it again? You want me to do it again?
I mean, I see
no,
it
it's clear, but I don't know what happened to mine.
Look now. Okay, watch me again. Start STDEV .s. We are using it. Double click on this, then highlight this. Okay, close it. Enter.
Yeah, this highlighting I said. I highlighted it and then everything changed to the first number, like the whole word changed to 72. That's the whole number.
Maybe you highlighted 72 by mistake. So just do it the way I do it now. STD when you get a chance.
Okay.
I click, then highlight from here all the way to the last one, not the one that you already calculated. Then close it. Then press the enter key. Then from here, put it right here, and then you can now from here. Once you see this cross is thick here, but when you put on this small dot, you change to the skinny one. Click, hold, and drag. That's it. Then you can then format and. So try it that way and see what happened. Okay.
Okay.
So now let us round up by now. So we have our mean for height and standard deviation. Mean is 72.5, which they wrote here as 72, 72.8. It's just a rounding error. I'm thinking that they did it for population. I got 72.5, and they got some 2.8. Let me see if they did it for population, or maybe I typed something numbers wrong here. Let me see. Equals average. Okay. I probably typed one number incorrect here, but this is how it is. Or maybe they made a typo themselves, because it happens. But the standard deviation is 3.4. They got 3.3. They got approximately 3.3. So once you plug it in for the height, standard deviation divided by mean, which is 3.3 over 72.8 times 100, you get 4.5%. Now, if you repeat the same process for the weight, you plug this in, they got the mean standard deviation as 17.7 and mean as 187.8. Let me see what we have. Mean is one. As you see, I got mean 187.8, and the standard deviation. They did it for population. Excuse me. If you look at they use delta, which is standard deviation for population. That's why we have 17 point something. Let me do it for population. See, STDE. Let me use it for population right here, and I'm gonna use this. It's probably either I typed something wrong, Oh, see, I got 17.7 because they did it for population. I did it for sample here. Say sample, their own is population. That's the only explanation for the difference in standard deviation. So you plug it in 17.7 over 1.187.8. 17.7, 187.8. So I have if I take you to the calculator, we have, I clear this, 17.7, excuse me, 17.7 divided by 187.8, okay, times 100, 9.42, that's 9.4, okay, approximately. I got 9.4%. So for the weight, for the height is 4.5%, and for the weight is 9.4%. So you can see that weight varies more than the height. So we can say that weight varies more than height. Then if it is a cost of living, you can say that the cost of living in New York varies more than cost of living in Baltimore, things like that. So that's how we use the coefficient of variation. Any question before we end the class for today? Any question?
No.
Professor, you said you would talk to me after class. Was that after this class, or did we need to pick a time or something?
Yes. Let me take you the attendance, then we talk, okay?
I'm sorry.
Let me take, oh, this is Mashi, right?
Yes.
Yeah, so I'm gonna read your email again, then give you tell you what to do, okay? So you don't have to wait.
All right.
So expect my response by because tomorrow I'll be busy all day. So Thursday, I got your back, okay?
Oh.
So we'll figure out something, right?
Thank you for
Okay.
having me.
So let me take your attendance and then we'll leave.
I do have one quick question. Didn't you say something about a tutor or someone that would be available to help with class?
Yeah, they have tutor online. You're gonna make an appointment. I'll find the link. I'll have to find the link. So give you the link.
Okay.
This is who again? Who? What's her name?
Me?
Yeah.
This is Vanessa.
Vanessa, yeah, Vanessa. So what I'm gonna do when I find the link, I'll post it on Canvas, so you can then make an appointment then. Okay.
Okay. No problem. Thank you.
And Darby, I would like to talk to you after class as well.
Darby, I have you here. This is 7/7/21. Bista, you're here, right?
Yep, I'm here.
So if I call you, you can leave. You can leave. Have a
good day.
Have a good night.
You too. Have a good night.
I got Darby here. Then I got Rita Ford.
Yes.
Then Dolly, I got Dolly here.
I'm here, sir.
So have a good night.
Yeah, sorry, quick question. The assignment, when would the assignment be due? The one
are you talking about homework 3?
Yes.
I'm gonna change the due date to next week.
Next week, weekend?
Yeah, next week Sunday. I'm gonna change the due date. I have not changed it yet, but I've been probably by Friday. I'm gonna update the due date.
Okay. Thank you, sir.
So I got Mashi. Mashi is gone, right? Yeah. Who else? Keshawn. Yeah,
Kishana.
I got it. I got your name now here.
Okay.
So have a good night. Who else?
You too.
Taylor. I got Taylor here. Kai Taylor. So Taylor, have a good night.
Okay.
Takia Docket, I got your name. What is it? Oh, yeah, I got it. So have a good night. Tiffany Walker. Tiffany. Have a good night. Who is TMO?
I'm here. Tiffany Walker is here.
Who is TMO? I marked you present.
Did you hear me?
TMO. Who is TMO?
Professor, did you hear me?
I hear you. Yes.
Tiffany Walker, she's here. But I did.
I've marked. Please, can you mute yourself on the background? Can you mute yourself? Okay, good. Tiffany Walker, I have already checked you present, so you can leave. Who is TMO? TMO.
Oh, I thought Dijon Dunson. I'm sorry. I don't know why my name won't.
Dunson. Okay, I got it. All right, I got your name now. You can have a good night. And
okay, I had one question. I had a question. So if the information, those sets of numbers are not in Excel, we don't get graded for that?
Excel assignment is different. You just gotta use Excel to get, if you want to use Excel or use calculator for your work, to do your homework.
Oh, I thought you said that yesterday, that you'll give us a 0 if it's not shown in Excel.
Oh, that is for Excel assignment.
Oh, Excel assignment.
Yeah, you have to do it in Excel, yes.
Okay.
If you don't do it in Excel, that one you can get 0. But for homework and quiz and tests, you have to just use calculator or Excel. It doesn't matter to me. Okay?
Okay.
Okay, Professor Oji, you have Vanessa, correct?
Yes, I have Vanessa.
Okay.
I got Vanessa already, yeah.
All right, thank you. Have a good night.
I got, who else? Kent, I got Kent. I think I got all of you now. So, got Kent. Miss Debbie, you say you want to talk to me? Miss Kent, I got you. Or is it Mr. Kent? I got you now. So, have a good night.
Yes, I did.
Rita, I have you already.
Okay, you were supposed to tell me, give me your schedule so we can meet.
Oh, my schedule is crazy this semester. So what I'm gonna do is I will check and say if I'll be free on Friday evening. I'll email you. So
okay.
So send me an email. You have my email, so I can email you on Friday. Let you know if we can, you know.
Okay.
Have a meeting, a Zoom meeting on Friday. Okay.
All right. Thank you.
Don't forget to send me the email.
I'm gonna send it to you in the inbox right now.
All right. Thank you. Now, Miss Debbie, what can I do for you?
So just a couple questions. I was looking at my assignments and I see I have missing assignments. So the discussions are actually due on Thursday and not Sunday?
Well, it's due on Thursday, but I still accept it all the way to Sunday.
Because
what I want you to do on Thursdays is that so that other students can respond. You see what I mean? Other than that, because of that. But if you don't complete on Thursday, I'll still and do it on Sunday. I still accept it, provided that it is done before midnight.
Because I did the one that said introduce yourself, and it said that it wasn't done, so I didn't receive any points. And then for the
you did it before the due date?
Yes. Now I didn't see the response. I didn't see that part, but I did put in like a sentence or so.
The introduction?
For the introduction, yes.
I didn't see.
And then for the Alexis assignment, it said that it was missing when it said to sign up. I obviously signed up because I was able to do the assignments in there. So I wasn't sure, was there something else I was supposed to do?
Yeah, because that was the first assignment to register and then take a picture of that show that you registered and upload it so I can give you the point in Canvas. Oh, you can still do it. You can still do it.
Okay, because I mean I did it because I've done the assignments in Alexa.
No, what I mean is uploading when you register, they give you a welcome, maybe that you showing that you registered. You take a picture and upload so I can see it, then I'll give you the credit.
Okay, and then I just received in the mail the regular, because I know you gave us a temporary code.
Yes, temporary code. Yeah, I provided a temporary code, but you already registered, right?
Yes, but don't I need to put because that's a temporary code that's going to expire, because that's what mine says. It says it's about.
Some of your class people, what they did is they took a picture of that code and uploaded it. You can do that, so I can see that you did it, and then I'll give you a credit.
Okay, well, my second question was, how do I put the permanent one in there? Because I tried to go back in yesterday and put in the code so it doesn't expire, but I couldn't find out where I could put in
Have you
another.
bought the book? I mean, have you bought the code?
Yes, so here's the code right here.
So it will explain on how to. I think on one of the
Yes,
book how
I
to,
did that.
before it should be there, and also before your code expires, they will send you a message with the information on how to extend the code.
Okay. Well, okay. So those were just my questions.
So go ahead and do it and upload it in. There's a place I provided for that to be uploaded. That was the first homework assignment. To upload it there, and then when I see it, and then I'll give you a credit. And if it doesn't allow you to upload it, just let me know. I can maybe open it for you. Okay.
Okay, and I guess I need to give you my number because I didn't get the message that class was starting late today. And I think I was supposed to give you my number for a text message.
You didn't get the Alex thing? You didn't get the messages from the test phone on the cell phone?
No.
In that case, just email me your phone so I can put it by tomorrow. In a mind, yeah.
Okay, that's all that I had.
All right. I see you next week then.
Okay, bye.
Bye-bye. Have a good night.